Hi, everybody. What an introduction. Gee, uh, my dad would have liked it. My mother would have believed it. um, thank you all for being here, and thank you particularly for the sponsors, to Brent and Chris and Peter. Thank you. It's a pleasure to speak with you today. My the topic that I was suggested to me to give is Geoadventures in the Grand Canyon National Park. Beautiful place. And so my goal here is to mix science with some of the beauty of the park and give you a sense for what it's like to do research in the park. Maybe a little bit of from the rim, from down in the canyon, and from the river running too. So hopefully there'll be a mixture of things to show you here. I've added a little bit here. Let's see. Uh, that also not advanced. Yeah. Oh, there we go. So yeah, I want to talk a little bit about beauty, groundwater, and some of the ecological challenges in the Grand Canyon right now with invasive species and things like that. Specifically, I'll start with the location. How many of you have been to the Grand Canyon? How many of you have been just to the rim? How many of you have been down in the canyon? Aha, an Arizona person. How many people have been down the river? All right, so this will be close to your time. A beautiful national park. I'll show you some pictures. Then we'll do some science, particularly the importance of springs. We'll talk a little bit about invasive species, particularly salt cedar or tamarisk. Uranium mining. I know there's a big mining community here, so we'll talk about uranium mining and some of the challenges in uranium mining. And finally, at the end, I'll throw in some river running and some videos for you. So I'll start off with just one of our presidents who helped establish Grand Canyon National Park. This is Deer Creek Waterfall that falls right down into the river. And this is his comment that we shouldn't mess with the park and try and improve it with, with, cable cars going up and down or trains going through. Leave it as is. And my philosophy was my Boy Scoutmaster said, leave your campsite cleaner than you found it. And so that's one of the things that I believe here. So an introduction, it's 485,000 hectares. Its visitation before COVID was about over 6 million people annually. And it came down during COVID, but it's coming back up now to almost 5 million people a year. Its elevation ranges from just about over 350 meters above sea level to 2,700 meters above sea level. I'll be talking at the end about river running, and one of the things you should know is when you put into the river, there's no roads into the river after that for 365 kilometers till the next road comes down. So you're pretty isolated. And then the next road that comes down is 450 kilometers down. It's got a varied and interesting hydrogeology, which we'll talk about here. It's not known as a cave park, but one cave they've recently found has more than 20 miles of passage, of 30 kilometers of passage, and it's a World Heritage Site. So first location of this, for those of you who haven't seen that, did you want to take a picture of that last one in the back row there? Should I go back one? Did you want to take a picture? Go. Got it? Sure. So it's located in the southwest of the United States. And if you look at the northern part of Arizona, this little section here is the Grand Canyon. So let's blow it up. And you have Grand Canyon National Park. The North Rim, which is about 300 meters higher than the South Rim. And the South Rim, of course, is down below here. Up at the top is a national forest, which just experienced a horrible forest fire. It went down into the canyon and wiped out the North Rim Lodge. Those of you who have been there, it was really quite a tragedy. Over on the left-hand side, you have Havasu Canyon. There's actually a Native American tribe that lives down in the canyon there, and they have beautiful waterfalls there. Um, just over on the right-hand side is the Little Colorado River comes in, and it flows this color sometimes of the year because of the calcium carbonate. But then other times when this is the Grand Falls on the Little Colorado, because of the sediment, it flows a different color. And then south at the very bottom here, there is a town just off the park boundary called Tusayan. My initial work there, I was worried that the wells in Tusayan were going to dry up some of the springs. So the issues there are spring environments and their habitats, which are really important. The springs are spread out, sometimes 15 kilometers apart. It's an arid area. Another thing is the Native American religious traditions and cultural identities there, which are really important. You have waste disposal on the rim. You have landfills up on the rim in Tusayan. And that's all growing. So a lot of people go to look at the Grand Canyon, and here's my vista here of the landfill up on top. Wastewater disposal up on the rim, this place called Clearwell Overflow. One of the springs down in the canyon, recently they found PFAS, per and polyfluorinated aliphatic substances, which are forever chemicals. So there seems to be a connection there. And then development up on the rim, housing development. This is a deep well up on the rim. And uranium mining, which will be a major focus of what I'll talk about today. That's an old uranium mine that operated right on the rim of the canyon called the Lost Orphan Uranium Mine. It operated for about 13 years from the 50s to 1969. And then it closed down. In the early days, I was sort of just trying to track and trace groundwater, and I was worried that the springs would dry up. So those of you who are familiar with this is a stable isotope diagram here. This is the meteoric water line. This is oxygen 18 here and deuterium here. And those of you who know what this means, down in here, we have the light isotopes, and up there the heavy isotopes. So these are North Rim springs in the red squares, which are lighter because it's a higher elevation. And then rainfall, which varies, are these triangles here. And then there's one spring on the South Rim in the green circle there that was a mixture of both. So the top is South Rim Springs, but then there was this one spring that was odd. And what happened is in the Grand Canyon, they take a spring in the North Rim and they have a pipeline that goes all the way down the canyon and back up to the South Rim that gives water for the South Rim. Well, they found out that the pipeline leaked, and it leaked North Rim water right near the South Rim spring, and that's why you have a mixture of these things right here. A lot of this work here is 30 years old, and I put this slide in just to show you, those of you who remember before PowerPoint, when we had slides, we had these pictures that were blue for our slides, and so we did some ICP-MS work, inductively coupled plasma mass spec. And this is, rare earth elements here. These are concentrations, aqueous concentrations relative to shale. And some of our early work was tracking and tracing groundwater due to its trace elements. The one that's weird down here is actually the sewage outfall from the South Rim, and it's different than the spring water trace elements here for the rare earth elements. So that's the work I did early on years ago. And one of the things we did is we looked at a lot of springs and we tried to see if there was mercury or arsenic or things like that. So here's one example. Arsenic, we looked at over 4,000 sampling events in the Grand Canyon Springs. 87% of the time, they never analyzed for arsenic. All right. When they did analyze, they got a non-detect for 11% of the time. Some detection was 88%, and when they did detect arsenic, it was above MCL's maximum contaminant level. That's the drinking water standard. So when they did analyze, the arsenic was usually above the drinking water standard. And so there were 78 springs we found that were above the maximum contaminant level of 10 micrograms per liter. So that's some of the early work. So now I want to show you pretty pictures to convince you that it's a special place. And we'll start up on the rim. A lot of you have been up on the rim. This is Mather Point. And I'm just going to go through some of these rather quickly, just to give you an idea of what it's like and how pretty it can be in the Grand Canyon. So these are all shots from the rim. Those are two of my graduate students. If you've never been on the rim recently, there's something called the Trail of Time. Two of my colleagues in New Mexico, Laura Crossi and Carl Kolstrom, they got a National Science Foundation grant. And as you walk along, there's a metal brass spike for every million years. When you take another step, it's another million years. And as you walk along, they have samples of rocks along this Trail of Time. This is one of them at the particular time, and they're beautiful. And you can walk a couple of kilometers along the rim and do the Trail of Time. So there's beautiful places up on the rim. Be careful, don't jump. But then when you go down into the canyon, there's a whole new world that opens up. And this is one of my graduate students, a guy named Jim Fitzgerald. Two of my other graduate students, Kim Zukoski and Lynn Metcalf. And just to give you an idea of Havasu Canyon. So once you hike down into the canyon, you have a whole different world that opens up to you. And there's one of my graduate students, Kim, is outstanding in her field. This is a place called the Silver Grotto. And if you run really quickly all the way around, you won't fall in, but you got to run really quickly. And then what you do is you have two people run opposite directions. And usually what you hear is, when we cross, you go low, I'll go high. And the other person says, no, you go low, I'll go high when you cross over. So yeah, this is the Silver Grotto. This is a place called Elves Chasm, and this person is mid-air jumping into the pool there, Elves Chasm. This is one of the springs, Jim Fitzgerald there measuring something called Page or Minor Spring below an old uranium mine. This uranium mine was mined for copper and uranium in the early 1900s. Uranium wasn't really popular in the early 1900s, but people thought it had medicinal value. In other words, people would wear uranium around their neck in a necklace and things like that, thinking that it would improve their health. There's some people here bushwhacking up canyon. There's a lot of bushwhacking. This is Steve Lawson, one of my graduate students, just before he jumped. This is another one here. This is called Dripping Springs here. Snow. Sometimes the snow blows sideways. Your water samples, you have to have them in your sleeping bag so they won't freeze. And in the middle of the night, if you want to roll over, you have to put your knees together on the stuffed sack of water samples and turn around. Some of the springs are very small and hard to get to. This is in Hermit Canyon. Some of them are fairly large. This is the one you saw before, Deer Creek. This is Elves Chasm, and this is what we call the route route. One of my grads. This is actually me, and my ex-wife, um, in the Grand Canyon, and this one I had hair. This is called Monument Creek, and that's the monument. This is Indian Garden, now called Havasu Garden. This is Fern Glen Canyon. The last winter light shining over the rim on this tree. Bass Trail, this is Darwin Plateau. This is Indian Toehold route that one of my buddies found. And you might be able to see, if you look carefully on the back, some petroglyphs back here. Again, all sorts of conditions. In the summer, it gets over 45 degrees sometimes. And so you hike before the sun comes up and you hide in the shade. And then when the sun goes down, you hike again. So yeah, this is the Grand Canyon. This is Hermit Canyon. Let's talk a little science now. Invasive species. 150 years ago, when the first people, not the first people, the Native Americans were the first people, but the first John Wesley Powell, the first U.S. Geological Survey people came through. There were no plants of this kind here. These are called salt cedar or tamarisk. They're very water greedy and they're very salt tolerant. They're an import from Europe to protect fields from wind, and they have gone crazy in the Southwest along water courses. So this particular study was looking at the age of some of these in different places. And this is Dr. Susan Mortensen, who was doing her PhD dissertation on that. Here's another shot of her. And so we would go through the canyon, and what we would do is, again, some of it was they allowed us to eradicate these and then cut them up. But some of the roots are very, very deep, and it's sort of backbreaking work. And this particular student here is doing a core to look at the tree rings data to see how old some of these things are, and at different levels and different terraces to see when these the tamarisk took seed. Also, we cut these down and made for a very heavy boat as you went down the canyon. This is to see the flexibility of some of the branches here. Of course, we brought computers along, Jerry Ledbetter. This fellow is looking at the sun because you have cliffs on either side. Different plants get different amounts of sun in different seasons. If you've ever gone down the Grand Canyon in the winter, you're in the refrigerator most of the time because the light doesn't get past the rim too much. And so you don't even have to tell your boating party if there's sun on a beach after 3 days. Everybody goes over to that beach. They lay in the sun for 15 minutes. One or two people will wash their hair, and then it's gone. So yeah, it can be very cold going down the river. I'd like to switch to uranium mining now. The United States produces about 2% of the world's uranium, and the Grand Canyon area and the Colorado Plateau, even a smaller percentage of that. And it is somewhat controversial. My research group was the first one to find high uranium over drinking water standards 30 years ago in a spring below Orphan Uranium Mine, which was on the rim of the Grand Canyon I described before. And so the Park Service put up some signs. I'll tell you, if it was the middle of summer and I was very, very thirsty, I'd drink the water anyway. But one time would be there. But these are pictures of the early miners in the area here, scaling cliffs. And then this is a cable car going down to the mine down below. Again, it ended in 1970, the mining operation right off the rim in the Lost Orphan Uranium Mine. But this is from one of my graduate students in March 2023, Colin Davidson's work. And all these concentrations are above the 30 microgram per liter drinking water limit. And so this is that side canyon. The mine used to be up here. Then there was an adit that went in right here, which is now collapsing on itself. Uh, it's in a formation called a breccia pipe, which I'll talk a little bit more about in the future here. But at the time when we first found it, we did all sorts of tracers. We did trace elements. One of the ones in the 1990s, there was still a tritium signature from the bomb pulse that went off. You know, we had these events in Nevada at the Nevada test site. They called them events. What they were bombs above ground, below ground. Some of the below ground ones were dirtier than the above ground ones because they vented all sorts of radioactive material in the ground from the ground into the atmosphere. There's a book out called The Day We Bombed Utah because that was downwind of the Nevada test site. So the tritium, what that means here is this would be younger tritium if there's more of it, and this would be older. And these are springs and the values, and this activity ratio is the uranium 234 to 238. The way that works is uranium starts as 238, and then it gives off an alpha particle, a helium nucleus, which is 2 protons and 2 neutrons. It burps it up. And the idea is, one of the theories is, as groundwater gets older, it gets more 234 because of what they call alpha recoil, like a shotgun. When you shoot an alpha particle, the 234 that's remaining goes back into the water. So one thing you can use as an older indication of groundwater is the higher this ratio is. If the ratio is 1, we call that secular equilibrium. And a lot of times with mining pollution for uranium, it'll be at secular equilibrium. You'll have a value of 1. So these are the different springs. These are old big springs. These are smaller springs that come out further in the canyon away from the rim, which are mostly younger. And the one in what's called Horn Creek below Orphan Uranium Mine, the one where we found high uranium, is this one right here. So sometimes you can find sort of like a fingerprint of secular equilibrium being one line of evidence could be if the ratio is 1, you might have nearby mining going on. The big question is it natural uranium or is it due to the mining activity? Well, let me just say one more thing about that. Uranium actually goes from a dissolved state to an ore solid state. It precipitates in low oxygen conditions, all right? In high oxygen conditions, the ore can redissolve in water and become mobile again. When you mine, you add oxygen. So you have and you also break up the rock and you have more surface area for water. So you have the potential to redissolve uranium and it can be remobilized, if you follow what I mean, in oxygenated conditions. So this is some of the early work we did on it. Other work to show that groundwater in an upper aquifer and a lower aquifer were connected were dye tracer tests. And this is from Ben Tobin, who is the chair of the International Association of Hydrogeologists Karst Commission. And in sinkholes, we put different dyes at different times. And we found very, very strange results. Here's one source where we put in a sinkhole of a dye, and it traveled 15 kilometers and came out here, and 20 kilometers and came out in springs here. This is the Grand Canyon here, and this is the closest place, and it didn't come out. Then we used a different tracer at a sinkhole further away. Some of it went that way, but some of it, even though it was further away, went down directly to the canyon. Those of you who have dealt with karst, hydrogeology, know that it can be very, very strange. And this is an example of it. But it did go all the way from the North Rim surface all the way down through. And that'll become critical when we start talking about uranium mining and the challenges with uranium mining in a moment. So this is a uranium mine that started operations when uranium prices came up a year and a half ago. It's the only uranium mine in the area. there was a moratorium put on new uranium mines, even though there are 1,000 prospects and people who have put in application for mining. So this is a mining area, and what we did is we flew over it and looked at radiation um, back and forth with different different passes, and we found high potassium, high thorium, and high uranium coming off the mine, and now it's even higher than it was before mining operations versus after. This is ground truthing on the bottom left. So how close is this mine to the Grand Canyon? It's less than 15 kilometers away. And so there's concern with the Native American tribes. There's 11 Native American tribes around the Grand Canyon. All the 11 are opposed to mining. The idea that this might affect the aquifers, that affect the springs, environmentalists are very concerned. And so this mining operation is the one that I'll tell you about. It's called Pinyon Plains Mine, and a lot of the movement of in this case copper and uranium is through fractured rock, and it's in what's called a breccia pipe formation, which I'll describe in a little bit. There's a 10-minute film called Too Precious to Mine, which talks about the economy of northern Arizona. The economy of northern Arizona is not mining, it's recreation. It's hunting, fishing, boating, things like that. It's not mining. The mining companies come from big international companies, although their subsidiaries are US companies. And there were a couple, I want you to notice right here that water is being shot into the air. And this is because a shallow aquifer that the mining company thought didn't exist was hit, and they hit a gusher. In other words, so much water came out that their surface impoundment here was not going to be able to hold it. Very, very high, way over the limit in arsenic and uranium in this. So they shot it into the atmosphere so it wouldn't overtop their impoundment here. And I'll talk a little bit more about that in a moment. So what is a breccia pipe? A lot of you geologists here know what a breccia pipe is, but let's talk about the Grand Canyon. Here's a sequence of rock here, Kaibab limestone all the way down here. And what happens is in the Redwall limestone, there's an aquifer down here, the Redwall Mauve, they call it. That's a Redwall Mauve aquifer. And then that's where the major springs of the Grand Canyon reside. That beautiful waterfall you saw earlier comes from the Redwall Mauve. Then there's an upper aquifer here, and that's in the Kaibab, Toroweap, Coconino, and Supai formation. And if you hike along the Bright Angel Trail, what you'll find is a contact between the Hermit, which is this one here. It's sort of an aquitard, and the Coconino. And if you look here, you'll see some travertine from some past water that's stripped down. In other words, the water comes down, hits that low permeability layer, and is shunted sideways out to the canyon. And so this used to be a spring. It's no longer one. And so there's a sample being taken from that contact there. So breccia pipe, you have a cave forming in the limestone down below. And what happens is the roof of the cave collapses. This is an example of the Redwall limestone here, and you can see these large cavities here. And what happens is the roof collapses and it propagates to the surface. And it's broken rock. Breccia is broken rock. So you have a chimney of broken rock all the way that propagates to the surface. It stopes upward. And in geologic history, water moves both from the bottom up and from the top down with uranium. And when it hits a low oxygen area, the dissolved uranium precipitates chemically and becomes ore. And so you get ore in this breccia pipe, and that's where the uranium is harvested by mines. That's where the mines want to go, in the breccia pipe. So um, one of the concerns is that there are 1,300 or more breccia pipes in this area. And the mine sort of insists that there is no connection between this upper aquifer and lower aquifer. And indeed, in the early days, when they did an environmental impact statement, they said there was no water here. Well, that's been disproven by actually when they sunk their shaft, so much water came out, they had to vent it into the atmosphere. But another concern is that they drill exploratory holes through this, more or less making it Swiss cheese. And so hydrogeologists, you have open boreholes and 17 and a half miles of open boreholes. What is that, about 30 kilometers of boreholes at different angles? So let's draw some of those in. There's one deep one. They only have one monitoring well right here. Um, Anybody who does monitoring knows to even find the direction of groundwater, you need a minimum of three in the simplest system to figure out what direction it's going. But that's their one monitoring well there. Here's their shaft. And here's some of the exploratory boreholes off that shaft, what I'm calling the Swiss cheese. And so there's concern among hydrogeologists that you might have migration between the aquifers of uranium, dissolved uranium. Single monitoring well, one of my favorite quotes is by Nevin Kresick, who is a past president of um, uh, the Karst Commission of the International Association of Hydrogeologists. And he said, based on my professional judgment, the Arizona Department of Environmental Quality, that's ADEQ, is nonsensical from a hydrologic standpoint, contrary to the entire professional practice of groundwater in any porous media and any type of aquifer, not just in karst. Okay, so most geologists know the 3-point problem for the, in the simplest homogeneous isotropic aquifer, which never exists anywhere, but you need at least 3 wells to figure out the direction of water. Well, you need a minimum of 3 wells to tell the direction. Another concern for this is, what if there's another breccia pipe next to it? And well, in this case here, you have to, the mining level, most of the low oxygen levels are in the Hermit Shale, upper Supai, but there's uranium down here in the upper Redwall too. You have to make a shaft down to bring the uranium out from underground. And so that's another hole with side grizzlies and shafts. And then you excavate cavities, which make it even more holy. I don't mean religiously, but I mean, more places. And so this is sort of a diagram of that. So that's sort of the background. So will uranium be mobilized with more oxygen? Will the aquifer be dewatered? In 1992, before one or two of you were born here, yeah, Brent, I argued before the Arizona Department of Environmental Quality that there might be an upper aquifer. And the mine said, no, we have a couple of holes with water in them, a couple of exploratory holes, but it's drip water and it's not much. Well, in 2014, they extended from about maybe a little over 120 meters down to, that would be about 700, no, not 700 meters, maybe about 500 meters. And when they did that, they hit a gusher. They hit so much water that they had to shoot it into the atmosphere. So you can see they started drilling this, and they completed it in 2016. And what I'm showing here is the micrograms per liter of, in this case, uranium in the lower and arsenic in the upper level. And this is what they're pumping out of the subsurface. Now, the drinking water level for arsenic is down here at 10 micrograms per liter. And here for uranium, it's 30 micrograms per liter. So you can see that this is well over drinking water standards, what they're pumping out of the ground um, for dewatering. What's perhaps more interesting or equally interesting is they're pumping in, I'm sorry, I have to do this in gallons, uh, 10 million gallons a year, 8 to 10 million gallons a year. Um, all these dots are breccia pipes. And in 2015, the Arizona Geological Survey posed a question. They said, do we know where all the breccia pipes are? So they took two squares here and here, and they examined them in depth to see if there were breccia pipes that hadn't been identified before. And they found 10 times the number of breccia pipes, which they think extends all over this area here. So, by the way, the mine I showed you, Pinyon Plain, where they had the gusher, is right there. So there are breccia pipes all around that one on the south rim. And now there's a new national monument which is dedicated to the Native American tribes. It's called the Ancient Trails. It's got another name which is hard for me to pronounce, but these are exclusion areas for new mining, but old mines, about 5 mines have been grandfathered in. And so environmentalists are concerned and the Native American tribes are very concerned. Let me just also say that the mining, the uranium here, goes up to Utah where it's milled. That's the only milling site in the United States, and it goes through Navajo country. The Navajo police don't like that. But it turns out that our highways are federal highways, and the Navajo police can't pull over the uranium trucks, even though they would like to. Okay, so here we have an upper aquifer and a lower aquifer. And what happens if you have a breccia pipe right next to the other breccia pipe? Maybe if the mines insist there's no connection between these aquifers, what if there is a connection and one they haven't measured next door? In other words, what if uranium in the groundwater goes to another breccia pipe and then goes down to the main aquifer? I'm about to tell you that the mines insist that there's no connection here between the upper aquifer and the lower aquifer, now that they have admitted there's an upper aquifer and a lower aquifer. Also, to set the stage of Native Americans in 1979 in Grants, New Mexico, was the biggest radioactive spill in the United States history. Excuse me, this earthen dam broke with tailings and sludge from the uranium mine. It traveled about maybe 150 kilometers into Arizona onto the Navajo reservation. And every year there's a protest about that particular 130 kilometers, excuse me, travel. So this is down in the Grand Canyon. This is the Havasupai tribe protesting. And in the upper left-hand corner, that's a circle dance in protest of the uranium mines. So there's a layer in the Grand Canyon called the Bright Angel Shale. And the mines insist that the geology of the Grand Canyon is simple, like a layer cake. And they've used that term, layer cake. So what I'm about, first of all, let me tell you, I'm all for responsible mining, but I have concerns about what the mines projected here. They said it was layer cake geology, that they're, so we called it the Energy Fuels, which is the company that's drilling there in the breccia pipe, the Bright Angel Food Cake layer. It was sort of a joke. And there's our breccia pipe there that they're mining in. And so the mine's argument was probably threefold. I'm going to mostly talk about two. But the dip is away from the south rim. In other words, the whole structure here is tilted toward the south, southwest, toward actually one Native American tribes. But they figure it'll take so long for the groundwater to get there, it'll be dispersed and it won't have high concentrations of uranium. So that's one of the arguments of the mining companies, that it's all going to flow to the south-southwest, even though it goes toward a recharge area. And then, so that's one of the arguments. Another argument is there's an aquitard layer that separates the upper and lower aquifers that's not fractured. And so those are the main arguments. Their original argument also was that there was no water up here, which is, now been disproven. So it's simple and easy for the uninformed to swallow that simple layer cake model. All right. Now let's talk about complications in geology and hydrogeology. Let's throw in aquifers. Now, if you know anything about karst aquifers, you know that they're kind of all over the place. So these are drawn in, the aquifers here. Maybe we should have named it a sponge cake instead of a bright angel food layer cake. But first of all, let's put in the aquifers. So the upper aquifer and the lower aquifer are here. Now, with a dye tracer test and things like that, I think you already know that there's several lines of evidence that these aquifers are connected. But let me go on. So here's one. Those of you who know what a stiff diagram is, it's the major anions and cations. This is the mine, major anions and cations, and these are springs. And you can see they're similar. One line of evidence that there's a similarity. Just one line of evidence. Dye tracer test, we talked about that before. And so now let's throw in folding. The Grand Canyon is an area where there's lots of folding. So let's fold this end on down here. There's several monoclines. So there's the hands, moving that down. There's a syncline. Let's push down and make a syncline here. All right. There's little folds and faults all over the place. So let's, we're pushing our fingers up and down through this layer cake. And so all these little red lines here are monoclines, synclines, anticlines, and the idea is it's pretty folded. And here's an actual picture of the Grandview monocline from the Grandview Trail. You can see how it moves here. There's a monocline. So we have now a folded thing. Now let's add faults. Ready? Here we go. Let's add some faults. Now these faults are pretty profound in some cases, and what they can do is they can draw groundwater and move it back toward the canyon, even though the dip is to the south. So there's many named faults, and a lot of them are major faults, and there are a lot more than just the 8 or so I'm showing you here. Some of the major faults are here, and then there's faulting that's in the other direction. But you can see here's the mine here, Pinyon Plain Mine. Here's the town of Tusayan. Here's the Grand Canyon Village, and you can see that any contaminated water could maybe follow any of these to springs of the Grand Canyon. And there's thousands of springs. Okay, the geologic cake is brittle. And so many small fractures can conduct water. So let's draw in some small fractures. Okay, now let's put in the breccia pipes. There's over 1,000 breccia pipes. So let's take an ice pick and let's go ahead and stab it there. Okay, now let's put the 17.5 miles or 30 kilometers of exploratory boreholes in. that you have a conduit for upper and lower. Let's put in the mining cavities and that are opened up, the shafts, the grizzlies. Um, and so the groundwater can flow between these. There's hydraulic head differences. The town of Tusayan pumps water out, so that changes the direction of groundwater flow in many cases. Um, and they're pumping out water here and dewatering because they hit so much water, they pump out 8 to 10 million gallons a year. So it's not only a water quality problem, it's a water quantity problem as well, that springs may dry up and go away. All right. How about earthquakes? I had kind of fun with this one. I'm sorry. I was getting a little bit loopy at this point. And lastly, let's do subsidence. In other words, after you create cavities, the mines can collapse. So post-closure, you can have open conduits and cavities. And so I'm sinking down here and it's going down. And let me show you the orphan uranium mine, the one that was on the rim, that's collapsing into itself. Uh, that hole's getting bigger and bigger every year. You can see some of the side side shafts here, but this hole is the lost orphan mine. It's just increasing every year, and so there's a concern about post-closure subsidence and collapse. So let's compare the hydraulic complexities of the real system with the Energy Fuels Bright Angel food cake, conceptual model, the layer cake, and there's one. And so this one probably we can forget about. And from a happy system that there's no problem, perhaps there are concerns environmentally with this. Particularly in a sensitive area with beautiful places. So now I want to end with some pictures and bring you down to the river just for fun. And so I'm going to show you some river running slides from different places and some of the work we're doing and just how beautiful it can be down on the river, but also challenging. There's some huge rapids. I mean, they're really big. And if you ever think of yourself as self-important, go down a big river in a small boat and it'll put things in perspective for you if you ever feel like really highfalutin about yourself. So this is actually my first trip down the Grand Canyon. I actually kayaked it and we had 3 rafts and one of them flipped in this particular rapid, which is called Crystal Rapid. If you know 1983, the canyon, we do cubic feet per second. It usually runs 8 to 12,000 cubic feet per second. It was 52,000 when we got on, went up over 100,000, all sorts of driftwood. I've got all sorts of stories. Big whirlpools, like 2 meters deep. They would take my kayak like going down a toilet and it would disappear from the surface. And I was just upside down in a vortex. I actually swam twice in this particular situation. There's me. Um, there's one of our boats going through Crystal Rapid. Other pictures of the river. But there's also beauty. There's beautiful, placid, quiet places. This is called Pumpkin Spring. It's shaped like a pumpkin, very high in arsenic, by the way. You okay? Okay. Yeah, I was kind of shocked too when I saw Pumpkin Spring. Um, this is actually, if you've never run a river that fluctuates, this is where the boats were parked at night, and in the morning the river had gone down. So there's an exercise, a group exercise thing where you have to push these fully loaded boats back into the river. The Little Colorado River, I think I showed you this before, can be like swimming pool blue. Fluting, beautiful fluting where there's um, erosion along the side. It's hard to describe just how beautiful it can be to be down on the river. I'm actually rowing there, but there's always time for beer. uh, oh, and food. You set up on the beaches and you cook food, and I'm not sure what I'm doing there. You can see the look on my face. This is the Vishnu schist in the bottom of the canyon. This is Lava Falls, scouting it, where everybody's heart is thumping and worried about how they're going to make it through. Um, let me see if um, oh, well, wait a second. No, this is not the video. I've got a, um, I'm not in the mode where I can turn the video on here. Maybe it's not this one. Maybe it's the next one. Yeah, it may be another one. Yeah, oh, yeah. When it rains, things appear. No, this is not a video. It'll be a video in a moment, but it's not advancing. Yeah, well, you get these sediment-laden waterfalls that just appear. Let's move ahead. No, this is okay. Hang on. Let me just move this forward. Okay, this is a video, and let's. Could you get this video to go? This is called Horn Creek Rapid. Yeah, there you go. Just a couple more slides. Those of you who have fallen asleep. Well, normally at this point, I have a bucket of water to enhance the experience. The next few are videos as well. As soon as it's done, go ahead. Um, this is called a Tiger Wash. I'm actually in the yellow boat off to the left that appears briefly, but this is a small rapid. Next one. This is Crystal Rapid, which is one of the bigger ones. And I'm actually at the oars on this one behind, it's being filmed by some people who are in front of me, ready to high side. You guys don't know what a high side is. I'll tell you in a moment. So I thought I was really good in this rapid. I missed some of the big holes, you know, um, but at the very end, you'll see that I kissed a rock. You see the hole I missed till uh, off to that side. Get away from the rock. I'm rowing backwards. And I didn't quite miss it. And one more. Now this one is called Upset Rapid, and that's me at the oars. And there's a guy named my teammates there. One's named Mo, the other's Korean. He's named Ko. And so this is Upset Rapid. And high siding is if the raft tips, you go to the high side to keep it from flipping. Okay, no more videos, just the next one. Yeah. So this is that same rapid, or Upset Rapid, and that's me in a kayak going through it on a different trip. You can see a cartwheel occurring there. And so the advice I would give the crowd here is be brave enough to suck at something new, or and don't be confused by the signs. Read them the way you want to read them. So, in summary, I wanted to show you a little bit about the beauty of the Grand Canyon, a little bit about Grand Canyon science, invasive species, the tamaris, groundwater springs and uranium mining, many tracers, multiple approaches, establishing multiple lines of evidence, and some river running at the end. And so that's my talk. If there's any questions, I'd be happy to answer them. And thank you for coming tonight.
Some questions on so people at home can hear your questions. If people at home have any questions, please start typing now. Oh, always the furthest person, isn't it?
Thank you, David. Fantastic presentation. I just have a query about the issues with respect to the national park, as well as the uranium mining and permits in America. So, for example, in Australia, if a national park is declared, there's no mining allowed. So, could you just please provide a bit of an explanation of the size of the national park when it was declared and the links to the uranium mining?
It was declared in 1906. The national park was declared, so it's been around a long while. I didn't explain this well, but the mining is actually not occurring in the park. It's in the national forest. And our national forest, the parks are in the Department of the Interior in the United States, one of our major departments. And then the Department of Agriculture is where our national forests are. Our national forests are multiple use. So you can have ski areas, you can have, dogs running around, you can have multiple things going on. You can have, ATVs on the dirt trail, things like that, which are not allowed in the national parks. So this is just off the park boundary. I mean, I said it's, less than 15 kilometers from the rim. It's less than 3 kilometers from the park boundary. And so that's why they can mine there. They can't mine in the national park anymore. That one on the rim was an exception, and it was sort of post-war uranium production during the Cold War era that people were very interested in getting uranium. Excellent question.
Questions on the floor here? Brent?
Thanks for that, Dave. Excellent. I'm going to ask you one about your traces, because with a scale at 25 kilometers that you trace those traces to. So 2 questions, if you can answer them. One is, what did you use as a tracer, and how long did it take for those to show up at your detection site?
Well, there's 2 types of tracers. One's an environmental tracer that naturally occurs. And we tried, looking at trace elements, and nobody had been looking at this in groundwater before. The big dream was, we could look at the trace elements and say, it's been in a limestone for 250 years, and then it moved to a tertiary volcanic, and then through alluvium and things like that. you can tell a little bit about where it's been, but you can't do that. And that and stable isotopes, environmental tracers. We did a lot of work that I didn't mention here with freons, with CFCs, chlorofluoride compounds. And, you know, in 1932, the first freon refrigerator leaked into the atmosphere. And in 1932 and a half, it's, you know, came down with rainfall, you know, and increasing amounts. And different CFCs started at different times, so you can get some time scale with that. So we use those environmental tracers. But the dye tracer tests are different. Those are ones where you put them in and you wait for them to come out. And in the North Rim, we've had a lot of success. In the South Rim, we probably didn't put in enough dye tracer. We found trace elements of some of these coming through, but not enough to definitively say that there was a hydrologic connection because the concentrations of the dye in the South Rim were so low. But on the South Rim, one of the, you remember that Monument one there? Monument Creek is where we found PFAS and where we found you know, other modern contaminants that have been around for a while, indicating that probably there is a connection between the sewage outfall for the South Rim and some of these systems. And Monument's kind of far away from the sewage outfall, which is in a different fault system. So it can travel, you know, at least 15 kilometers sideways. So that's an injected tracer. The South Rim needs more of that to figure that out. Good question. Other questions?
Yeah, again, that was really entertaining. Thanks, Dave.
Sure.
A lot of the interpretation, particularly around the uranium mine, was based on spring observation, and they had one well at the mine. Does the state have a network of monitoring wells to understand what's happening in that upper and lower aquifer, or were you really just constrained to those natural locations of discharge?
There's sort of a history to the Pinyon Plain uranium brecciopite. The first is there were no monitoring wells except for the one deep one. And they assumed that if uranium showed up there, there was a problem. Even though, if you know karst, you can have dilution factors and things like that with karst flowing in different directions. What then happened is when they hit the upper aquifer, and they were mining in the upper aquifer, they realized that maybe we ought to put some monitoring wells in. And so not only the U.S. Geological Survey, but the mines themselves put in 3 monitoring wells. They, you know, their theory was it would move down dip to the southwest, and those 3 monitoring wells would show that. No, it actually showed it, you know, moving to the northwest with the, you know, heterogeneity. Well, with the anisotropy. And so the upper aquifer now has some monitoring wells. But just in the last year, there's been such an outcry from scientists, from hydrogeologists, that there might be a problem with connection and dewatering of the lower aquifer and contamination of the lower aquifer, that now the USGS, along with the state of Arizona, has finally started a study to see if the 2 aquifers are connected. And I'm not sure if they're going to put in more monitoring wells down deep, but they're starting tests to see if that's the case. One of the things is in the deep monitoring well, which is also a supply well, they have found CFCs in it, which are, you know, fairly modern. And they only tested once, and they found them, and they stopped testing for it. So now there's a whole study to see the connection, and the EPA, our Environmental Protection Agency, also did a study, and their conclusion was there's a possibility of connection. And so it's moving in a direction I think that's positive, but it may be too late. You know, the damage, if there is damage, we might not know it for 10, 15 years, you know, time bomb effect. So hopefully the monitoring will help answer those questions.
Good, thank you.
I'll ask one.
Any online questions?
I'll come. Quick. The obviously CFCs and other things, the groundwater age is, or the recharge is fairly recent. Is there any isotope work elsewhere suggesting that some of it may be quite ancient, or is it all still fairly quick recharge?
It's really a mix. It's a mix for a couple of reasons. Some of the water is, some of it's epigenic, some of it's hypogenic. Some of it is warm water that comes from below into these breccia pipes, and some of it is comes from above. They've done some sulfur isotopes which show a correlation with a layer that's above the uranium layers, indicating that there is at least a component of let me go back. Sulfur is a reductant, sulfides, and when it hits a sulfide layer, gypsum or whatever, that's when the precipitation of uranium occurs. So you have to have that reductant there. Well, the source of that reductant in the recent sulfur isotope tests seems to come from above. But then there's a real possibility that there's been hydrothermal activity. If you go off to the east 150 kilometers, there's diatremes. There's actually water that's burst up from below. These are not diatremes because all the breccia pipes end in the Mooney member of the red wall limestone, and they would go deeper if it was a diatreme coming up. And so, in answer to your question, it's really a mixture. There, you have ancient waters, you have indication that there's relatively recent water, but what has actually been measured sometimes when they've done groundwater ages, it's pretty old. And what they found one time is that the shallow water was older than the deeper water, which was, in some of their age dating. And those of you who've done age dating know that if you look at carbonates, the problem is you can get dead carbon. In the limestone, you have carbon-14, but it's been there so long, it dies. So, it goes through its half-lives, and it's dead carbon. So if groundwater that's got carbon-14 from above comes and mixes with it, it looks artificially old because it picks up that dead carbon and you don't have as much carbon-14. So it's really kind of problematic. The error bars are pretty big in some of the dating that's gone on. And in answer to your question, I think it's a real mixtures of water that hasn't been totally defined. Question?
Thank you for your presentation.
A little louder, please.
Excuse me. I wanted to ask you, is there any example of like canyon in the woods?
Any extraction?
Any example? Like canyon in the woods?
I still can't hear you.
Yeah.
Oh, canyons around the world like this. Well, the Grand Canyon is pretty unique, especially it's so colorful. In Mexico, there's something called Copper Canyon, which is actually deeper, but it's not so colorful. It doesn't have it has layers, but they're not as exacting. So yes, there are other places in the world with very incise, deep canyons. There's not any that, the one in Mexico, I think they have a train going through at the bottom. This one's pretty unique that you hike down in the canyon and you're alone. I did a hike sampling trip alone many years ago. I started on January 5th and I went down one trail and I came back up 6 days later. I've got one. And I didn't see another human being for 5 days.
There is another example of canyon in western of Iran.
Oh, that's Horseshoe Bend?
Yeah.
Oh, yeah, I've been down the San Juan River, but
Yeah.
it's not as deep.
It's younger than Arizona
Yeah.
canyon, and but both is limestone, shale, and sandstone.
Yeah, there's.
In the shale,
She's showing a picture of a
exactly-
big meander.
Which one is for you? Yeah.
The one in the bottom is U.S. That one's Iran.
Exactly. Good example of canyon in US.
Yeah,
Yeah.
yeah. It's not quite as deep, but it's
folding Douglas plate, Arabic and Douglas plate.
Oh, yeah.
Yeah, because of that, in folding, after that, erosion of the river. But in US, that is just erosion
No.
of river. I think.
Yeah,
Thank you so
that
much.
is sure. There's some huge meanders in some of the rivers. The Green River, which flows into the Colorado River, which I recently had a fairly interesting trip with high winds and big waves and high water and no campsites. But there are a lot of meanders in these big, deep canyons that are, you'll travel for something like 10 kilometers and come out just less than a kilometer away from over the hill from where you started in one of these large incised meanders.
Thanks, Dave. I know USA has some statewide numerical models. How do they manage this beast inside those big models? And has some idiot tried to do a local model of this?
You're talking about a mathematical model of this? Good luck. No, actually, some researchers from Northern Arizona University in Flagstaff, which is one of my university and that university are the closest to the Grand Canyon, and they did some modeling, but it's so complicated. And as you know, mathematical models and when you start dealing with computer modeling and you have to simplify. And all the simplifications don't take into consideration all the fractures and all the faults and all of that sort of thing. So it has been modeled. I'm not sure the models are worth very much because of the assumptions that go in and the simplifications that go in. Good question.
Thank you. Any other questions?
Anything online?
The sponge cake is the best.
I'm sorry?
The sponge cake is the best model.
Yeah. The Bright Angel food cake is was one of the working models, and I don't think it is anymore.
Easier from the people at home. So no, there's no questions from
Okay.
Stunned. You probably had one or two and they're happy. On that note, I think we're getting had a fantastic night. Thanks very, very much to Dave and to our sponsors for bringing Dave over here and making sure we had a fantastic night.
And I've told a couple of people, if you've gambled away your money in Las Vegas, we live in a small town just outside, just give me a call. We have a guest room in the back. I'll find whatever gutter you're laying in with your half empty alcohol bottle, and we'll give you.
Don't give my secret away.
You're always welcome, and thank you for being a wonderful audience.